10.7. So we're going to talk about areas of circles and sectors. All right, so hopefully we all know how to find the area of a circle. What's our formula for finding the area of a circle? Area is pi r squared, units squared. And r is our radius. So on your graphic organizer, on the back side where it's all about circles, you might want to put in the next blank circle, the area of a circle, pi r squared, where r is the radius. You might want to put that in one of your circles. So there should be a blank circle where you can put in the area of a circle. So just as a quick example, just showing how we're going to, just a quick example of doing this. Here's my circle, and I'm going to draw this. And I'm going to say this is 48 feet. And we want the area. So how would we calculate the area of this circle? Area equals pi times, what are we going to put next here? 24 squared. 24 is this, what we have here is the diameter. So we have to find the radius, pi times 24 squared. If we want an exact answer, we would just square 24, and our area would equal 576 pi square feet. Or if we wanted an approximate answer, we would multiply 576 by pi, and we get 1809.6 square feet. So this would be our exact answer, or our answer in terms of pi, and this would be our approximate answer. Yes. All right. So hopefully finding area of a circle shouldn't be too much of a new thing. All right. Are we all good with this? Okay. So now we want to find. We know how to find the area of the entire circle. We want to be able to find the area of parts of the circle. So the next thing we want to talk about is a sector of a circle. Let's draw a picture of a sector. When we're talking about a sector, we're talking about a wedge, a piece of pie, a piece of cake that we're cutting out of our circle. So here is our circle and my center. A sector always comes from the center. And we're cutting out a piece of that circle. So we're talking about the shaded piece here. So that shaded piece is a sector. And I'll call this center P, that point R, and that point S. So the shaded part is the sector. We name it sector RPS. So we name it kind of like a triangle. The P is like the vertex of our triangle. Each side of the sector is the radius. And the plural of radius is radii. So the sides of our sectors are radii. The area of a sector is a fraction of the area of the entire circle. I'm just cutting a piece out of it. So we need to figure out what fraction to find the area of a sector, we're figuring out what fraction of the circle it takes up. Well, the fraction that we're going to use is the same fraction that we use for arc length. We look at the angle and figure out what part of 360 that angle is. And that's going to tell us the fraction of the circle the sector takes up, and then we're going to multiply that by the area. So in your graphic organizer, you have another circle. You want to label that one area of a sector. So in your next blank circle, area of a sector. And I'm going to say, I'm going to draw a little picture here, and you can draw the picture in inside the little circle there. So I'm going to call the center of the circle O, and we'll talk about our points. We'll call our points on the circle A and B. So here is A and B. So our area of sector AOB is the measure of arc AB, the angle measure, divided by 360 degrees. That's the fraction of the circle that arc takes up. And then we're going to multiply that by the entire area of the circle. So that would be your formula for the area of a sector. The arc, the measure of the arc, the angle measure of the arc divided by 360 times pi r squared. And this angle measure of the arc divided by 360 is the same fraction that we use to figure out the arc length. This tells us how much of the circle that sector takes up. So we look at the measure of the central angle, or the measure of the arc, divide that by 360, and multiply that by the entire area. Make sure you have that formula in your graphic organizer. All right, we're good with our formula. Same fraction we use for arc length, but we're multiplying by the area because we're talking about area rather than length. All right. Let's look at an example finding an area of a sector. So here's our picture here. And let's say this is 94 degrees. And we'll call this S or ST. So we want the area of sector RST. And we need to know one other thing. Our radius is 9 millimeters. So our area is going to be the fraction of the circle that this sector takes up, 94, divided by 360. That tells us what fraction of the circle that takes up, times the area of the entire circle. So that gives us the fraction of the area, times pi times 9 squared. And I'm going to plug this into my calculator. This is going to give us some decimal, so I'm not going to worry about my answer in terms of pi. So I'm going to grab my calculator, plug those numbers in. So 94 divided by 360, I get 0.2611. So this is 0.2611 times pi times 9 squared is 81. And I'm just going to multiply all this together. 0.2611 times 81, and then multiply that by pi. I find my pi button here. Just do 3.1. Go. And I get about 66.44 millimeters squared. So the area of that sector is about 66.44 square millimeters. Find the fraction of the total circle that the sector takes up and multiply it by the area of the circle. That's what we're doing. Questions there? Good with that example? So we're doing the exact same process that we're using for the arc length, except instead of multiplying by the circumference, we're multiplying by the area. Exact same thing. All right, the last thing we need to talk about today are segments. So a sector is a wedge, a piece of pie, a piece of cake that we're cutting out of the circle, right to the center. A segment is a little bit different. So we want to figure out how to find the area of segments. So let's draw a picture of a segment. So here's my circle. And I'm going to draw a sector. And then I'm going to connect the endpoints there on the sector. So I'm cutting this triangle out of the sector. This shaded part up here is a segment. So I take a sector and I connect the endpoints where the radii meet the circle. I connect those endpoints, and this little piece up here is the sector. Or sorry, the segment. To find the area of a segment, and this would be another good thing to put in one of your circles on your graphic organizer, area of a segment. We don't really have a formula, but we have a process. So I'm going to draw 3 pictures that tell us our process. So we're going to first find the area of the sector. And I'm going to shade that in. We're going to take the area of the sector, and we're going to subtract. I'm going to put a minus sign there, so we're kind of making a little symbolic equation here. We're going to subtract the area of the triangle. So now I'm going to just find the area of this triangle. So I'm going to draw the triangle here. We'll shade that in. So the area of the sector minus the area of the triangle equals, that's going to give us the area of the segment. And I'll shade that. So to find the area of a segment, we have to find the area of the entire sector. We subtract the area of the triangle, and that will give us the area of the segment. The area of the triangle is nice because 2 sides of the triangle are the radii, are each a radii of the circle. So we'll be able to use that information to help us find the area of that triangle. We find the area of the sector, subtract the area of the triangle, and that equals the area of the segment. So you might I would recommend either writing this equation, area of a sector equals area of sector minus area of triangle equals area of segment. And you could also draw this little picture in there to help you remember how how this is going to work. All right, so I want to do one example of finding the area of a segment. Just going through this process. So to find the area of a segment, we have to find two different areas. So let's look at an example. So here's my circle, and we're going to make this a (90-degree) angle, 7 inches, and we want to find the area of the segment. Well, we know the area of the segment is the sector minus the triangle gives us a segment. So let's find each piece. Let's find the sector. The area of this entire sector is the fraction of the circle that it takes up. That is 90 divided by 360 times the area of the entire circle. So times pi times 7 squared. That gives me the area of the entire sector. Well, 90 divided by 360, what fraction of 360 is 90? 1/4. So that's 1/4 pi times 49. If I find a quarter of 49, this turns out to be 12.25 pi. So that would be the exact answer of that area of that sector, and that's approximately, if I plug that in the calculator, I get 38.48 inches squared. The area of the triangle, let's find that next. Well, let me draw the triangle separately here. Here's my triangle. There's 7, that's 90 degrees. What's the height of this triangle? 7. Each of these is a radius. This side is 7, that side is 7. So the area is 1/2, the base, 7 times 7. 7 times 7 is 49 divided by 2. And that is exactly 24.5 square inches. So the area of the segment is 38.48. The area of the sector minus 24.5, and that comes out to be 13.98 square inches. And we'll have to, in order to find the area of these triangles, they'll have to give you, you'll have some information, a nice kind of triangle that will let you find the base and the height. So you'll either have 90-degree angles, you might have a special right triangle, a 30-60-90. This one turns out to be a 45-45-90. So you'll have to be able to find the area of that triangle somehow. So if they give you a problem where you're finding the area of a segment, there's got to be some way for you to find the area of that triangle. So if you're not sure, think, do you have a 45-45-90? Do you have a 30-60-90? Can you use those special rules? Or can you use trigonometry? Can you use our formula 1/2 BC sine theta, BC sine A, 1/2 BC sine A, to find the area of the triangle? So we have ways to find the area of the triangle. They're not always going to be this easy to find, but you will be able to find the area of the triangle. All right, are we good there? So we should have our area of a circle, area of a sector, and area of a segment that we added to our graphic organizer today. All right, our homework. All right, so there's our homework. You will be turning in